Hello again, students. Mr. Reeves back with you, and we are going to continue working through solving systems of equations by graphing. Now we're going to look specifically at uh, solving problems that involve systems of equations, and our method for solving is going to be graphing. Later on, we'll be solving problems using systems of equations, but we'll be solving them using either substitution or elimination. So I just wanted to bring to your attention that the textbook recommends that when an equation is in standard form, again, ax plus by equals c right here is in standard form, they recommend that you solve for y and put it in slope-intercept form. And while you are certainly welcome to do that, and that was part of your instruction on graphing equations in standard form, that's not the way I'm going to be doing it. I prefer to make the tables to graph equations in standard form. But I did want to make you aware that the book teaches it that way, and you are welcome again to take these equations from standard form and to put them into slope-intercept form and graph them that way. All right, let's dive in and do a couple problems. Here we go. So, actually, we're going to skip one more page over. We are on page 234 in the Math 8 textbook. It is module 8.1, solving systems of linear equations by graphing. All right, so here we go. It says Mrs. Morales wrote a test with 15 questions covering spelling and vocabulary. Spelling questions X, you can see on the X-axis, they've assigned spelling questions to be X, are worth 5 points, and vocabulary questions Y, so here's the Y-axis with vocabulary questions Y, are worth 10 points. The maximum number of points possible on the test is 100. All right, so let's make sure right up front that we understand that we're dealing with two unknowns. We have a test that Mrs. Morales has created, and what we don't know is how many spelling questions there are and how many vocabulary questions there are. So X is the number of, that's not hashtag, number of spelling questions. And Y is going to be the number of vocabulary questions. So when you are setting up and solving these systems of equations, make sure that you start off with an understanding of what your X and Y actually stand for. All right, because then when you're asked to write the equations, it should be easier. It's definitely hard to write an equation when you don't know what your variables represent. So let's take a look. It says she wrote a test with 15 questions. All right, so what does that tell us? That tells us that there was a total of 15 questions. Now, what were those questions made up of? They were made up of questions that covered spelling and questions that covered vocabulary. So the total number of questions is 15. And when we see that word total, all right, it tells us that we're going to add. So our first equation, we're going to have a system of equations, and our first equation is going to be X for how many spelling questions there are, plus Y for how many vocab questions there are, equals 15. Does that make sense to you? There's 15 questions on this test. Some of them are spelling, some of them are vocabulary, and together it makes 15 questions. But this test is also worth points. It says every spelling question is worth 5 points. So spelling questions are worth 5 points, and vocabulary questions are worth 10 points. And the total here, this is another total, is 100. All right, but this total was total questions, right? Total questions. And this total is total what? Total points, right? Total points. So I'm going to have another equation over here, and instead of equaling 15, this one's going to equal 100. And I have an X, and I have a Y. All right, but x plus y doesn't equal 100. Remember, x is the number of spelling questions. There's not 100 questions. This is points. What does it say? Every spelling question is worth 5 points. So I need to put a 5 here because each one of these questions is worth 5 points. And each one of these questions is worth what? 10 points. So now you can see that I have my system of equations, and these equations indeed are in standard form. All right, so the book says to write a slope-intercept form to represent the number of questions on the test. So we went ahead and wrote a standard form. So I'm going to go ahead and strike this off and not really worry about the slope-intercept form. We have a standard form equation, and that is x plus y equals 15. If we wanted it to be in slope-intercept form, we could subtract x from both sides and have y equals 15 minus x, or negative x plus 15, but we're not going to worry about that, okay? All right. And then right here, again, write an equation in, we're going to do an equation in standard form for the number of points on the test, and that's our second equation, 5x plus 10y equals 100. Again, if we wanted this in slope-intercept form, we would have to subtract this 5x and then divide by 10, but we're not going to worry about that. All right, now graph the solutions to both equations. All right, here we go. So this is where I recommend, when you have an equation in standard form, to make a table. And if you watched the previous video, I did this when I had an equation, or now I have an equation, x plus y equals 15. I'm going to put in 0 for x and 0 for y. When you make a table of values for an equation, said this before, I'll say it again, you could pick anything you want for x and find the y that goes with it to make the equation true. Or you can pick any value for y you want and put it in the equation and find the value of x that makes it true. We are simply picking these two because 0 is the easiest number in math to work with. So we have our first equation, x plus y equals 15. Right? So if I go ahead and put in 0 for x right here, I get 0 plus y is 15, or y is 15. Or in other words, if you think about what this means, if there are no spelling questions, then there has to be 15 vocabulary questions. So I'm going to come up right here and I'm going to plot that point. When there are 0 spelling questions, there's going to be 15 vocabulary questions. That point is right there. All right. On the other hand, if there are 0 vocabulary questions, then there must be 15 spelling questions, right? So do you see those 2 points are the 2 points from our table right here? Now again, it's nice to have more points than just 2 on a line, but in this case, it's pretty easy to connect, and I'm going to go ahead and connect these 2 points. Now I'm going to remove the arrows because this doesn't keep going. We're not going to have negatives in this problem. Right? If I kept going down, that would make negative number of vocabulary questions. And if I kept going this way, that would make a negative number of spelling questions, and we don't want that. So all of our answers are in between here. All right, so we could have 0 and 15. Take a look at this one right here. So that's 5. 5 and 10, that also adds up to 15, right? 10 and 5, that also adds up to 15. Right? We're not going to really have parts of questions, so technically this line really shouldn't be solid like this. But this would represent all the number of questions we could have that add up to 15. All right, so now let's go ahead and make a table for that second equation. This equation was for the number of questions. Now let's do one for the number of points. Let me move this out of the way. I'm going to make a table again for my red equation, my points equation. Once again, I'm going to put in 0 for x and 0 for y. So I have my equation 5x plus 10y equals 100. The first thing I'm going to do is put in 0 for x, so 5 times 0 plus 10 times y equals 100. When I divide by 10, I get y is equal to 10. So that means that when x is 0, or when there are 0 spelling questions, I can have 10 vocab questions. Because what is a vocab question worth? A vocab question is worth 10 points. And what's 10 times 10? 100. So this is how I could get 100 points having only vocabulary questions. But what if I make vocabulary questions 0 instead? I'm going to go over here and go 5x plus 10y equals 100. But this time I'm going to put in 0 for the vocabulary questions. So 5x plus 10 times 0 equals 100. Well, 10 times 0 is 0. I get 5x equals 100. And when you do 100 divided by 5, you get x is equal to 20. So that means if I have 0 vocabulary questions, I can have 20 spelling questions. Because what's a spelling question worth? A spelling question is worth 5 points, and 20 times 5 is 100. And then if I go ahead and connect those, that gives me all of the possible ways that I can add up to 100 points with these constraints of 5 and 10 points per question. And as I was making that line, I hope it jumped out at you, that is, that right here I have a point of intersection. And remember, every ordered pair has x comma y, so I have 10 comma 5. 10 comma 5 is the point that makes both equations true, right? 10 is x and y is 5. All right, so if we were to put that in the first equation, we would see that 10 plus 5 equals 15. It makes that first equation true. And if we do 5 times 10 plus 10 times 5, we get, excuse me, we get 50 plus 50, which is 100, which also makes it true. So we made the first equation true, we made the second equation true. So what does this tell us? Again, x is the number of spelling questions, so that means we have 10 spelling questions, and we have 5 vocab questions. And if you have 10 spelling questions and 5 vocab questions, you will have 15 questions and 100 points. All right? So there's an example of a word problem set up in standard form. Again, going back to the beginning, we identified what our x and y were, and then we took the information from the problem and we wrote 2 equations. One that involved the number of questions, one that involved the number of points. As you work through these, you'll see there's a lot of similarities. You're going to get 2 equations every time, and many times one involves a number and another one involves value. All right. Okay, let's take a look at another question. This one that turns out to be a problem that turns into slope-intercept form instead. So now I'm on number 7, and this is on page 235. Again, in module 8.1, number 7. It says the table shows the cost for bowling at 2 bowling alleys. We have Bowl-O-Rama that charges $2 for a shoe rental fee and $2.50 per game. While Bowling Pins charges $4, they charge you twice as much to rent shoes, but they charge you only $2 per game, 50 cents cheaper. So this one starts cheaper and goes up higher. This one starts higher and goes up by a smaller amount. All right, now if we go down to the graph, you will see that they have actually picked the variables again for us. If they hadn't, we would be able to pick what we wanted x and y to be, but they have here the number of games is x and the cost is y. The number of games is x and the cost is y. So I'm going to go ahead and write that up here because it's always good to know what your variables stand for, and it's good to write them down. So x is going to be the number of games, and this would be the number of games that actually are played. And y, this is a y is going to be the total cost. All right. Now, if we take a look at this and I said, well, what does the total cost depend on? The total cost depends on what? The number of games you play. We're assuming you're only going to rent shoes once. So when you go bowling, you don't rent shoes every game. You don't play a game and put the shoes back and then pay for the shoes again and play another game and then put the shoes back. No, you just rent the shoes once the entire time. So this is a one-time fee, right? And this one right here is a recurring fee. This one occurs over and over and over again. It occurs wow, that's pretty bad. Let's try this again. This occurs every game, right? Every game we're going to be paying this. This is a one-time. And hopefully you remember from when we did problems like this before, when we have this one-time fee, that generally is our y-intercept. And this recurring fee, that is our slope. So we're going to be looking at equations that are going to be written in y equals mx plus b. You'll notice this is different than last time our equations turned out to be in standard form, ax plus by equals c. But when you have problems like this with that one-time fee and a reoccurring fee, you get equations in slope-intercept form. All right? Okay, let's see if we can remember that and come down here and do some work. All right, so let's write our two equations. All right, so here we go. And I seem to be fond of having a blue equation and a red equation. All right, so y is our cost. So I'm going to make this my blue one. I'm going to make this one my red one. So what is the cost at Bolorama? All right, well, what does it start with? What is my y-intercept? My y-intercept is $2. I'm actually going to put that second because it's y equals mx plus b, right? And I'm going to go ahead and put the red equation down here. What does the red equation start with? It starts with $4. So you walk in to go bowling. At Bolorama, you pay that $2. At Bowling Pins, you pay that $4. Now that you've got your shoes, now you go over to bowl. And when you're at Bolorama, it's going to cost you $2.50 per game. So I'm going to put 2.5 for $2.50. Now, how many times are we paying that $2.50? We pay it every game. So I'm going to put 2.5x because remember, x was the number of games we played, right? So if I just bowl one game, it'd be $2.50 plus $2. If I bowled two games, it would be $2.50 times 2, or 5 plus 2, which is 7, and so on. All right, let's do the same thing for bowling pins. Bowling pins is going to cost me $2 per game. So here is my system of equations right here. There's my two equations, both in slope-intercept form. And what is my goal? All right, my goal is to find the solution to this system, to find the x and the y that makes both equations true. Got it? I want to make both equations true. All right, so 2.5x plus 2 and 2x plus 4. So let's go ahead and go to the graph. All right, let's start with the second one first, 2x plus 4. So I'm going to write it down right here. Y equals 2x plus 4. So the y-intercept was 4. Remember, that was the cost for shoes. And then it goes up $2 every game. So if I play one game, it goes up 2. By the way, this scale here is going by 2s. You notice these scales don't match, right? This one goes by 1s. This one goes by 2s. So one game is going to cost me $6. Two games is going to cost me $8. So even though it looks like I'm going up by ones, right? I'm actually going up by 2s. And I'm going to do what I should have done last time. I'm going to make this dotted, because really you can't play part of a game. I mean, you could play part of a game, but they're going to charge you for a whole game. That's the way it works. Or nowadays, a lot of times they charge you by time rather than by the number of games. But this one is set up by the number of games. So I'm going to put dotted lines to show that we're really not playing part of a game. All right. And that was our second one. So now remember what our first one was. It was y equals 2.5x plus 2. They only charge $2 for shoes, right? But every game it goes up by $2.50. So one game would be $4.50. Now, this right here is 6, right? So 4, 6, 8. So $4.50 is going to be kind of hard to do, right? This is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. All right. But let's see if we can actually get a point that's actually on the grid. All right. So if I play one game, right? One game, it's going to cost me $4.50. And I'm just going to put the decimal here just to save space. If I play 2 games, it's going to cost me another $2.50 on top of that. What is $4.50? Sorry, if I play $2.50 on top of that, that's going to be 7, right? If I play 3 games, now it's going to be at $9.50. And if I play 4 games, then it's going to be at 11. And if I play 5, whoops, it's got to go up by 2.5. I'm sorry. 12. There we go. That's the one I was looking for. Do you know why I was looking for that one? Because that number 12 is actually on the grid. So when you're plotting these, you don't actually have to plot every point. And a lot of times students make all kinds of crooked little lines. So I'm going to go to 4 games is going to cost me $12. All right. So just a quick check here, right? 4 times 250 is going to be 10. 10 plus 2 is 12. And hey, that happens to be my point of intersection. So I'm going to make this one blue, and I'm going to connect those points there as carefully as I can. All right, so you can see the cost is lower for the second one until we get to here. And what is this point of intersection? It is 412. By the way, if you don't believe me about these other points, if we go back 1 and 4.5 should be about right there on the line. 2 is at 7. 7 is right in the middle of 8 and 6. Do you see that? 3 is at 9.5. We're getting just below 10 right there. All right, so do you see if I had plotted those points carefully, they would be on this line? It's just nice to go when you find one that's exactly on the grid. All right, so what did we find out? Again, the first point, the first part of every ordered pair is x, and the second one is y, and x was the number of games, right? And y was the cost. So what is the point of intersection? When we have 4 games, the cost is $12 for both bowling alleys. All right, so for the first one, which was actually this blue one here, it starts off cheaper, and you'll see it's cheaper. That blue line is lower than the red line till we get to that point, and after that it's higher. And the red line here is higher till after that point it is lower. So 4 games cost $12. The solution as an ordered pair is 412. So what is the solution? 412. What does it represent? 4 games cost $12 for both bowling alleys. All right, so I hope that helps you see an example of a question in standard form and a question in slope-intercept form. Thanks for watching the video, guys.